UKMT Grey Kangaroo 2021 paper. So this is the extension for the Intermediate Math Challenge for years 9 specifically in England, whatever the equivalent year is in Scotland and Northern Ireland. So it's slightly easier than the pink Kangaroo, which is for years 10s and 11s. It's got the same rules, 25 questions, 1 hour, I think, and you don't lose any marks for getting anything wrong, so you may as well guess things that you're not sure about. And let's get straight into it. So what's the value of this? Well, the mistake here would be actually bothering to multiply these things together. What you want to do is do the pro gamer move of just adding the numbers on the bottom and then working out that 20 is the same as 5 times 4, and then we can cancel these 5s, and now all you have to do is 4 times 21, which is 84. So that's question 1 done. Never do the maths, always do something more intelligent. Question number 2, so clearly when we put these pieces together, it must start with this one on the left, because it doesn't have anything there. And clearly, likewise, this must be on the right. But I think actually the only one that this can connect to, because it doesn't connect to this, because that would end the chain immediately, is this one. So I can put that one there. This one must be on the end, as I've said. And now we think about the middle two. Well, okay, this is the only one that can connect into this too, so that one must be there. And then this slots in nicely in the middle. Good. 2 minus 102 is minus 100. Question number 3. So each of the vases contains has a max volume of 1 litre. Half of that is poured in. So for something completely symmetrical like this will just be half the way up. And actually, something like this will also be half the way up. Now this will have something slightly lower. Actually, it will have something slightly higher. No, it won't. It will have something much lower than half when you fill in half of it, because the base is wider, so there's more to distribute out lower, and this is the opposite, right? Because this is thinner at the bottom, the water will pour in faster higher, and when you put in half of it, it will be higher than halfway up, because it's got more volume to take in up here, where it gets wider. So A is going to be the one where it's the lowest, D is going to be the one where it's highest, A is going to be the one where it's highest, D is the one where it's lowest because it opens the bottom. These are actually all symmetrical top to bottom, so these are all going to be right in the middle. But A is the one where the water level is the highest because it's thinner at the bottom, so the water will pour up and get higher quicker, and then it will slow down as it gets to the top when it winds up. Question number 4. So from here I can read that B plus D is 7. Now it could be 17, because then I'd carry a 1 over down here and I'd still end up with a 7 here. Not sure, but okay. A plus C. Now if B plus D was 7, A plus C is clearly 13. But if B plus D was 17, like if it was 8 and 9, then A plus C would only have to be 12, because you'd carry the 1, and then if A plus C was 12, you'd add that to make it 13, and then carry the 1. So we've got these two timelines, and I do this later on in the paper as well. I'm just working with two different timelines and seeing which is correct. So here, B plus D, well that makes a 7, we know that. Now, does it carry the 1 or not? As in, is it a 7 or is it a 17? Well, it actually doesn't matter, because if it's a 7, then C and A are 13, and I put a 3 here. If it's a 17, then A and C are 12, and I add up a 1, and I get a 3 anyway. So there's a 3 here no matter what, and also there's a 1 carry here no matter what. One thing to note here is that C plus A obviously is the same as A plus C, so it doesn't matter that they flipped the order of these. Likewise, D plus B is the same as B plus D, so again, we have the same thing here. This is either 7 or 17. Either case, though, you add this 1 and you get an 8 there, and then I'm not sure whether to carry the 1, but it's the same as what we saw before. Doesn't matter. If I do carry the 1, if there is a 1 there, then A and C are 12, and I just get a 3. If I don't carry the 1, A and C are 13, and I get a 3 anyway, with a 1 left over, and you get this here. So that's the answer. That's quite a nice question. Question number 4. So there are 10 digits here. 0 to 9 is 10 digits. So therefore, 0 is opposite 5. Because there's 1, 2, 3, 4 in the middle of those two, with 6, 7, 8, 9 in the middle of those, so there's an equal number in between. 1 is opposite 6, same reason. 2 is opposite 7. 3 is opposite 8, and 4 is opposite 9, so that's good. So here we're looking to be opposite. We're going to turn these 180 degrees, so we're looking at the opposites. Opposite 6 is a 1, so this or this. Opposite 3 is an 8, so it's this one. And just check the others work. Opposite 4 is a 9, so that's good. And opposite 8 is a 3, so that's also good, as we've already said. So it's this one B. Number 6, okay, so I drew this one terribly. Here's a chocolate bar with an unknown number of squares. I couldn't be bothered to draw them all in, partly because I don't know how many there are. Now, I've put 6 rows here because she takes off 2 complete strips, and I'm going to say that's these 2 strips to get And when she did that, she took off 12. Right, so she took off these two things, and she took off 12 bars. Now it says Jack breaks off one complete strip of squares and gets 9 squares from it that he eats. Now he can't be breaking off this strip because that would only give him 6. So he must be breaking the strip off this way instead. So there must be a further 1, 2, 3, 4, 5, 6, 7, 8, 9 blocks here, and that's the end of the chocolate bar. And he'll break off those 9, leaving this many blocks in the chocolate bar, which is 9 times 5 for 45 left over. And number 7, when a jar is 1/5 filled with water, it weighs 560. So let's say that the weight of the jar is G. Oh, no, that's called a J, isn't it? Yep. And the weight of the water we'll call W. But we'll say that's if it's full. So if the whole thing is full, the water weighs W. That means that J plus 1/5 W is 560. And J plus 4/5 W is 740. Now at this point, this is obviously a simultaneous equation. At this point, I thought about timesing both sides by 5, but then I realized I couldn't be bothered to do this and this times by 5. So what I did instead was I just did this one immediately take away this one. The J's cancel, and you just end up with 3/5 of W equals this minus this, which is 180. Now if you divide both things by 3, again you could solve for W here, I still couldn't be bothered. Just divide both sides by 3 to get 1/5 of W is 60, and then just put it straight into here, which means J is 500, once you put that in. Cool, number 8. In this diagram the area of the large square is 16, so therefore clearly the large square has sides of 4. Each of the smaller corner squares are 1, so each of those has side length 1. What is the shaded area? Well, if these sides are all 1 in the corners here, and this side is 4, that means that this side is 2 from this corner to this corner. And also, if the distance across is 4, and this is clearly the midpoint, that means that distance is also 2. So to work out the grey area, one way that I thought to do it was to say that, well, the whole area is 16. This doesn't make sense for a minute, but bear with me. The whole area is the 16. So the shaded area is 16. Take away 4 lots of ones of these. So that's 4 lots of these 1 by 1 squares. Take away 4 lots of these other white squares. So the shaded area is 16. Take away these squares. Take away these squares. These triangles. Because each of these triangles is a half times 2 times 2. Because they're all symmetrical. So that makes 4. Obviously, that makes 1 times 2 is 2 times 4 is 8. And we get the answer of 4 in total. Costa is building a new fence. He uses 25 planks of wood. So let's make this diagram much bigger. Each plank is 30 centimeters long. So if there was no overlaps, and there are 25 planks of wood, if he just laid them out end to end, you'd have 25 times 30, which is 750. I literally just tripled this. It's 25, 750, and 755, and then added the 0. That's 7.5 meters. Now, he hasn't got 7.5 meters. He's got 6.9. So if we call the little overlap x here, what I need to do is I need to count how many overlaps there are, and that will be the difference between these two things. So let's count how many overlaps there are now. Okay, he's got 25 planks of wood. That means that I think there are 13 planks on the bottom row, because there's just one more on the end here, and 12 on the top. And each of the top 12 planks has 2 overlap bits. So I think that means there are 24 overlaps, because I worked out there are 12 blocks on the top, and each one has 2 overlaps on it. So 24 overlaps. So that means that 7.5 minus 24 overlaps of length x equals what we've actually got, 6.9. So let's move those things over to get this. At this point, I can't remember what I did. I think, I said this is 60 centimeters smart because the answer is in centimeters. Excellent. And then I divided by 24, except I didn't. I did something smarter. I just divided by 6 because I don't have a calculator. And then I just divided that by 4, which would be 2.5, because I just know that one. Cool. Question number 10. So 5 identical right angle triangles. So the right angle is like here, right? So the right angles are there. Can we arrange this than this? Okay, so look at this center bit. That has 5 identical angles here, because the triangles are identical, and an angle of 360 all around it. So 360 divided by 5 is 72. So each of these triangles has a big acute angle of 72. If the other angle is 90, then this means that last angle is 180 minus 90 minus 72, which is 18. So now the question is saying, if you actually flip these triangles over and put all the little angles in the middle, how many would spiral around to make a shape like this? Well, it will be the opposite of this, right? It will be 360 divided by 18, which I can simplify, divided by 2, and then maybe divide by 3, and I can say that's 20. So 20 of them would fit in, going around with this angle instead of this one. Question number 11. So if that square has length area 1, it also has length 1. And what I'm going to do is I'm just going to call the length of this square x. Okay, which means the length of this square is x plus 1. And likewise here is also x plus 1 because it's a square, which means the length of this square, because this is also 1, is x plus 2, because it's x plus 1 plus 1, which is x plus 2. And likewise this square is x plus 2 plus another 1. So this square is x plus 3. And now this square, remember, was x, and this is 1. So this little distance here is x minus 1. This is a spoiler. This distance here is x minus 1 because it's x here and then take away the 1. But the whole length here, remember, is x plus 3 because this is the square here. So x plus 3 is equal to x minus 1 plus something, and that something must be a 4. That came in slightly the wrong time, but that's okay. This length is a 4 because that plus that makes this here. Question number 12. 20 questions in a quiz, 7 for a correct. So let's call correct C. The number that you get correct is C. The number you get wrong is W, and the number you leave blank is B. That means that C plus W plus B is 20, because you're answering 20 questions. And this person, Erica, scored 100 points. So 7C minus, because you're getting 4 deducted for each one you get wrong, minus 4W is 100. And we need to make some sense of this and work out what B is. So how do we do that? Well, okay, what I did was I said this is an integer question, right? Like you can only get a certain integer number of questions correct or wrong. So what I said was, okay, let me get out some multiples of 7. So here are some multiples of 7 around 100. And now I couldn't get this multiple of 7 because then I couldn't take away 4 lots of something to get 100. But I could get this multiple, right? I could get this one because then I could take away 3 wrong answers. 3 times 4 is 12, and I would get 100. This doesn't work, this doesn't work, this doesn't work. None of these are multiples of 24 above 100. So actually this is the only one that works. Of course you could go further and get more that work, but actually this is already 19 times 7. So if you're getting 19 questions right, you'll get this score. If you get 20 questions right, you get another, and then there's no space to get any wrong anyway, so you can't go down to 100 again. So this must be the one of how many you got right, which is 7 times 16. So then you must have got 3 wrong, and that gives you a score of 100. 16 correct and 3 wrong is 19 in total, which means only 1 was left blank for you to get this score. Occasionally very helpful to think about the fact that you're working in whole numbers, and then you can just kind of trial and error some things together. It's a very useful strategy sometimes. Question 13. So we've got a rectangle for 4 and 13, so this distance is obviously 4 here and also here. The reason it's here is because I noticed this is an isosceles triangle, so this is angle 90, which means this is 45 degrees as well. 45 plus 90 is 180, so this is an isosceles triangle. So this is 4. Actually, I could have said this is 4 just because, yeah, that folded bit there used to be over here, like this bit, so that was 4. Anyway, okay, so this is 4 as well. What I did next was I said, well, if this side is called y, now this side used to be like here, right? When you unfold this, this length kind of comes here. So therefore, x plus 4 plus this y, which should be there, is this whole 13. So that's what I've said here. This bit over here is saying, well, the area of this p is 4 times x, and the area of this q is 4 times y. But I know in here that p is equal to 2q. So 4x is equal to 2 lots of 4y. Cancel the 4's, and you just get x is 2y. Now I already explained this bit here. X plus 4 plus this y, which should be here, if you unfold it, is 13. So that means x plus y is 9. But I know x is 2y, so I'll put x in here for 2y, or 2y in here for x, I guess to say. 3y is 9, and then y is 3, which means x, looking back here, must be 6. And that's the answer I think that they wanted. Quite a involved strategy there. I think there were probably some easier things you could do if you were a bit smarter. Question 14. Okay, so a fruit box contained twice as many apples and pears. So this is classic Mr. Drew time of just making something up. I'm just going to make up that this fruit bowl had 2 apples and 1 pear. Chris and Lily divided them up. Always choose a really easy example. Never make it overcomplicated. Just choose a nice, easy one. Lily and Chris divided them up, so Chris had twice as much fruit. So I'll just say Chris takes the 2 apples and Lily takes the 1 pear. I mean, so now we had this, which satisfies this thing, and this, which means Chris has twice as much as Lily, which satisfies that thing. So that's fine. Okay. Which of the following is always true? Chris took a pear. Not true. My example says no. Chris took twice as many apples as pears. Not true. He took 2 apples and no pears. Twice nothing is nothing, so not true. Chris took twice as many apples as Lily. Lily took no apples. Twice nothing is still nothing, so not true. Chris took as many apples as Lily took pears. He took 2 apples, Lily took 1 in my example, not true. So this must be the only one that's true. I can't be bothered to put any more thought into whether or not this is actually a reasonably correct statement, because I know I've discounted all of the others. Surely there is some way to logically think about this and how it must be true, but if you're just discounting all the others, one of them has to be, apparently, so this is it. Good. Question number 15. Maybe there's some smarter way of thinking about that. Anyway, let's call some distances then. So let's call this distance from this place to this place A, and this distance B, and this distance C. Now it says from this place to this place, the detour is 1 kilometer longer. So that means A is equal to C plus B or B plus C take away 1, because this detour is 1 kilometer longer. So to make them equal, I'll just take away 1 from it. Likewise, for the next one, it says from D to M, the detour is 5 longer. So if I do the straight route, I need to take away 5 from this route to make it equal. And likewise for the other one, to take away 7. Okay, now I want to work out, I've got 3 equations, I've got 3 unknowns. This is a solvable thing when you've got 3 equations, 3 unknowns. Often it's just a case of lucking out into something that works really nicely. I just decided to put this statement for A, B plus C minus 1, into here. So you're about to see me just say C equals, and then this A, I'm just replacing exactly what was here, and then I'm just going to copy everything else down. So this A I've just put in as what I know it is here. And this actually worked out beautifully because the C's, if you just take away C from both sides, just go away. You got 2 B's here and you got minus 6. This solves for B. B is 3. So I know B is now 3. Now, I don't know that that's the shortest length, so I need to find the others now. So let's put B as 3 into the other ones. So there we get this statement, and if I put B into 3 into this one, I get this statement. And now that means that A and C are 2 numbers such that when I add them together, I get 10, and the difference between them is 2. I can think of 4 and 6. They do that. So A is 4, C is 6 will do that, and that actually means that B was the shortest distance. So the shortest distance is 3. Yeah, I highly doubt you did that in the same way I did. It's often just about lucking out into a nice quick solution when you're doing 3 equations, 3 unknowns. There are systematic ways of doing it, just like there's a systematic way of doing 2-dimensional simultaneous equations, but it's, usually you just want to luck out into something a bit better than that. Anyway, question number 16. Oh, classic round 2 of Mr. Drew doing classic Mr. Drew things. In a fraction, the numerator and denominator are both positive. Let's just choose a fraction. There we are, there's a fraction. And let's not do any algebra, let's just make up this fraction and do this. So the numerator is increased by 40%. I chose 10 because increasing it by 40% is nice and easy. Makes 14, no decimals or anything to mess around with. By what percentage should the denominator be decreased? So I'm going to times the denominator by some decimal multiplier to decrease it. And apparently when I do that, I'm going to make twice the original fraction. Okay, so I can set up this. This looks solvable for m. 2 times 10 over 20. I chose this because I read the whole question and realized that choosing a half would make this nice. This just makes 1, which means 20 times m is 14, which makes m 14 over 20, which is 0.7. So m is a decimal multiplier that is 0.7, which of course corresponds to a percentage decrease of 30% if you know your decimal multipliers. So yeah, 30% is the answer. Question number 7. So I think that I only did this question in this way because I've done a lot of math challenges recently, and they always ask you to do the thing that I did, but they give it to you, right? So it was on my mind, even in a question like this where they don't give you that idea. So instead of multiplying this thing by 3, I added it to itself in a column 3 times to make this number here. Which is very unusual, because the whole point of multiplication is so that you don't have to add the things up like this. But because they've given me so many questions that look like this, I thought, oh, I could do it like this, couldn't I? And so, okay, so t plus t plus t is some number ending in 2. So it's either 2, which it can't be because t is a digit, it's a whole number. We can't have 3 lots of that being 2. So it can't be that. It could be 12 though, or it could even be 22, except it couldn't because 22 isn't a multiple of 3. So it must be this one here. T plus t plus t is 12, which means t is 4. So t is 4, and also we carry a 1 here when we do t plus t plus t. S plus s plus s must equal t, except it doesn't. It equals 1 less than t because you use this 1 to make it into t. So s plus s actually equals 3 because then we use this 1 to make it into a 4, which is what t is. And now this works perfectly. S is just 1. So s is 1. And that means r plus r plus r, and there's no carry here. Look, there's no carry because you just get 1 plus 1 plus 1 is 3, and then add the 1 for 4. So there's nothing to carry here. We just have r plus r plus r is s, which is 1. Now that can't be the case because again it's whole numbers. So what about 11? Again, 11 isn't a multiple of 3, but 21 is. So we get r is 7 using this, and there's 2 to carry over here. And then we have q plus q plus q isn't 7, it's actually 5 because we need to add this 2 to make 7. So q plus q plus q is 5. That can't happen, not a multiple of 3. That can, so q is 5. Again, there's something to carry over here because that makes a 15 look. So there's a 1 here to carry over. P plus p plus p is q, except it's not. It's 1 less than q. So p plus p plus p is 4. That can't happen. So what about 14? That can't happen. 24. P is 8. And then we'll just double check. We get a 2 carried over here because of this 2. 2 plus 2 plus 2 plus 2 is 8, which we know p is. So we've got this correct. This is the number. 2, 8 is p. Q is 5. R is 7, S is 1, T is 4, add up all the digits. This is the bit that I think, for me at least, is most likely to go wrong. Do it carefully. 10, 15, 22, 23, 27. Good. Question number 18. Quite a visual question, this one. There's a few of those coming up, actually. I'm going to assign this face of balls to be here. So I'll say that that's this face. And then notice how this one here links up, this DADA, so that's this ball, DADA. That links up to this face, so this face must be on the back here. And this DADA, those are all shared balls on this thing here. And then we've got these ones over on the back side over there, because we've got DCBD linking up with DCBD. So that's on the back there. So these are the kind of sides on the top of the pyramid. And then we've got the side of the balls on the bottom here, which I need to think about. Now, okay, how many... there are 20 balls in total, and there are 4 of each color. So how many balls have we currently accounted for is my question here. So we've got, well, one. I'm definitely going to stop saying balls and start saying spheres, just because it's starting to catch up with me. Maybe I've been watching too much The Office, but from now on I'm just going to say spheres to make sure the giggling stops in the audience. But anyway, so how many spheres have we got so far? Well, we've got so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 here. Now, I don't just want to count these 10 because remember, all of these are shared. So I've got the 10 here, and then I haven't counted these ones yet. So that's 11, 12, 13, 14, 15, 16. Now, all of those are shared, so I've already counted all those. So I'm at 16, 17, 18, 19. Sorry, but this line is also shared with up here. So I've got the 10 from here, 11, 12, 13, 14, 15, 16, and then all of this is shared, so I've got 17, 18, 19, and I'm only missing one sphere, which is kind of on the bottom, in the middle of the last kind of tray, right at the bottom here. I've only got one missing sphere. So all I need to do is count which lettered spheres I've already got 4 of, and there should only be one letter that I've only currently got 3, and that one will be the one that's down here in the bottom somewhere. So let's count the A's first. We've got 1, 2, and neither of those are shared, right? Because they're not on the edges. So they're not sharing anything with these edges. So I've got 1, 2, 3, which is shared with that, and 4, which is shared with that. So I've got 4 A's. What about the B's? I've got this one, which is shared here. So that's just 1. That's the same sphere. 2, which isn't shared. 3, same as this. And then 4, which isn't shared. So I've got 4 B's. C's, I've got 1 here, which is the same as this. That's just 1. 2, which is the same as this. 3, which is on its own. 4 on its own. So I've got the C's. D's, got 1 here, which is actually just all of this. That's the same sphere. 1, 2, which is the same as this. 3, which is the same as that, and that's it. I've only got 3 Ds. So the last one, there must be 4 Ds, so the last one in the bottom, tucked in the middle there, is a D. Question number 19. Okay, there are 12 pentagons apparently. I can see 6 of them. 1, 2, 3, 4, 5, 6. So if I were to look at the ball from the exact opposite side, what I would see is this. I would see the other 6 pentagons, and notice how I've just rotated the football slightly, because if here, just beyond the crest of this, there would be a white hexagon, which is this white hexagon here. Right. So, and likewise, just beyond this hexagon, there'd be a black pentagon, which is this one there. So I've just slightly rotated it, and now I think everything is different. I can just count. I can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I can count there. And then I should be able to count another 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 here. So there are 20 in total. Good. Question number 20. This is really interesting because there's actually a very equivalent question in the pink kangaroo of the same year. So it seems like they like reusing questions and just putting a slightly easier version on the grey and a slightly more difficult version on the pink. So anyway, the smallest digit number whose digits add to 41. Now, the smaller number, the fewer digits a number has, the smaller it is. So 99 is smaller than this, despite having the same digit sum. Digit sum is 18 here and 18 here, but this is much smaller because it has fewer digits. So the smallest number that has a digit sum of 41 just is loaded with 9s and then just a remainder number. So, well, 4 times 9 is 36. So I can put 4 9s in a number and a 5 to make it go up to 41. So the number looks something like this. Now, the reason I used a 5 and not maybe a 3 and a 2 is because if I used a 3 and a 2, that would make the number 1 digit longer because I'd be using an extra digit. So that's not okay. So I just want to use the 5. Now, this isn't the smallest number that adds to 41 because the smallest number is, of course, when you put the 5 first. Because, again, smallest first digit, smallest number. So this is the smallest number whose digit adds to 41. And now let's just add 2021 to it. So let's get our column. 9 plus 1 is 10 with 1 left over. 9 plus 2 is 11, carry the 1 for 12, 1 left over. That makes a 9, 10, 1 left over. 11, other one is 12, 1 left over, 6. And then the digit sum of this number is 6 plus 2 plus 2, which is 10. And that's the answer. On the home straight, question number 21. Now, I did this question in an incredibly scuffed way. I have also since, it's one of the few that I actually read the mark scheme for. So I'll do the mark scheme version as well, just in case you don't understand my version. What I thought to do was, okay, let's consider a simpler version of this problem. Instead of considering the 3D shape, let's just consider the 2D shape on the front and pretend we're going from this corner to this corner. How many boxes does that pass through? Well, it passes through 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now, what about if we were to just go from this corner to this corner? That passes through 1, 2, 3, 4, 5, 6, 7. Okay, and now we've kind of in our minds got to combine these journeys together to get from here to here. So we'll start in this box, which is the same kind of thing as this box, right? We'll go across, we'll start going across and up, and we'll hit another box. And then we'll hit another box, that's 1, 2, 3. But then as we're doing that, we'll also pass into the second row up here. So we'll go through 1, 2, 3, and then pass into the second row, so that's the fourth. Then we'll start going across again and up, so that's 5, 6. Then we'll go across into 7, and then again we'll pass into a third row here to make 8, and then we'll start going through 9 and 10. So I think that's 10. Let me do that again just in case you didn't quite follow. Starting at this box, we go across, start heading across, we head through this box and this box, then we head into the second row, so that's 1, 2, 3, and then we head into the back row to make the middle row to make 4. Head across, keep going across and up, so that's 5, 6. We're not passing into the next thing yet. That's 5, 6, 7, and now we pass into the next box, but we also head upwards as well, so that's going to be 8, 9, and then we finally get to 10. In case you didn't follow that, which I would not blame you in any case you didn't, this is what the mark scheme said. The termite only passes through faces of cubes because it doesn't pass through any edges or corners. So to get from, it's kind of similar to me, consider the one-dimensional case. To get from the front to the back, it's got to pass through 2 faces. To get from the left to the right, it's got to pass through 1, 2, 3, 4 faces. And to get from the bottom to the top, it's got to pass through 1, 2, 3 faces. Every time it passes through a face, it goes to a new cube. So it starts in one cube and then goes through 9 other faces, therefore 9 other cubes. So therefore it's 10 in total. It starts at 1, passes through a face 9 times, therefore 10 numbers in total. Okay, question number 22. Draw it. A to B. Lewis drives at 70 miles an hour to B. We'll say that the distance is d from A to B for now. That's d is what we're trying to solve for. His speed is 70. So speed equals distance over time means that his time taken was distance over speed, so that's d over 70. He stops here for an hour, and then he travels back 105 kilometers at 70 miles an hour. So we can actually work out the true distance here. We can work out the actual time taken, we know the distance, by doing 105 over 70, which simplifies down to 3 over 2, which means 1.5 hours. Now, all while this is going on, Geraint is cycling at 30 miles an hour from A, and he's going all the way to here, and he meets Lewis, having travelled d minus 105, because d is the whole distance, 105 is distance, so he travels d minus 105 at a speed of 30. Okay, that means that what we can say is d minus 105 over 30 is the time taken, and because it's distance over speed again. And this time, the time it took him to get to here, is the same as the time it took Lewis to get here, stop, and then get here. So d minus 105 over 30 is equal to this, plus this, plus this. And this is just something that I can solve. So I can say this is equal to this. I times everything by 70. No, I didn't. I put those together, then times everything by 70. Then I times everything by 30, just to get rid of the fractions. Then I expanded out, took away 30d, added those two things together, took away the zeros, and then divided by 4. 4 goes into 12 3 times, 4 goes into 6 1 time with 2 left over, 4 is in 25, so it's 315. I'm just going to adjust the mic really quickly before we get into question 23. And we're back. Question 23. So again, this is another question that's very similar to a pink kangaroo question, just slightly easier. There's a bunch of coloured balls. I'll just do the first 10. In any 3 balls, there are 3 different colours, red, white, or blue. So let's just make up a colour scheme. Let's say 1 is labelled white, 2 is labelled red, 3 is labelled blue. That means if we look at these 3 balls, they must have a red, white, and blue, which means this must be white. And then if we look at these 3, they must have red, white, and blue, which means this one must be red. If we look at these 3, then they must have red, white, and blue, so this one is blue. And what you notice is that the pattern must be always repeating. It's just forever repeating. It just goes red, white, blue. In this case, red, white, blue, white, red, blue, white, red, blue. And this, I'm not saying this is the actual way that it goes, but this is just an example. But it must always repeat, whatever the actual thing is. So this must be a white in this case, then red, then blue. And what we can see here is that when we think about it in terms of multiples of 3, the multiples of 3 are always blue in this example. The things that are 1 remainder multiples of 3, 1 above a multiple of 3, are always white. And the things that are 2 above multiple of 3 are always blue. And we're going to use that fact. So she's guessed that koala 2 is white, and she's also guessed, which means that white must also be 5, because red and blue must be here, and then you must go back to white, and therefore here, red and blue, you must go back to white. She's also guessed 2021 is white. So basically, I just want to know where, so the whites in this guess are 2 above multiples of 3. So I want to know what this is. So if I divide it by 3, I find that it's also actually remainder 2. So if koala 2 is white, because 2 is 2 above a multiple of 3, and so is 5, and so is 8, and because 2021 is also 2 above a multiple of 3, that means 2021 is white if 2 is white. So if 2 is white, then 2021 is, because they're both 2 above a multiple of 3, which means they both must be right, because only one of her guesses is wrong. So if this guess is wrong, then this one is, and likewise if this one is wrong, this is. So they both must be right. Then we look at actually this, koala 20 is blue, but 20 is 2 above a multiple of 3. Multiple of 3 is 18, add 2 is 20. But we know the whites are taking up the 2's above multiples of 3 slots, so this must be wrong, because it's also white, and I don't need to consider these big numbers, which is good. So B is the wrong one. Question 24. Okay, so I made up two timelines here. So what I said was I considered the missing teams in each round. So in the first round, the missing teams are RSTU, which I can see are the names of the teams from these things here. Now I can see in game 2 R is playing S, so R can't play S in round 1 because they're playing each other in round 2. So this means that you either have a timeline where R is playing T or where R is playing U. So we've got top timeline and bottom timeline. If in top timeline R is playing T, that means S must be playing U. And in this timeline, that means S must be playing T. Okay. Now in round 2, the missing teams are P, Q, T, U, because R and S are playing. But look, I know that P has already played Q, so they can't be playing each other. And I also know, I think I can see just one game ahead, that P is playing T in round 3. So P can't be playing T here, and it also can't be playing Q because it's playing them either side here. So P in this round must be playing U, and Q must be playing T. So there's no timeline here. I've put it in the middle because this must be happening. I know everything about round 2. These two are playing, these two are playing, these two are playing. Round 3, these are the missing teams because P and T are playing each other on TV. So now R has already played S from round 2, so R is either playing Q, or I could say it from S's point of view. S is either playing Q, which means R is playing U, or S is playing U, so R is playing Q. Doesn't matter what order you write those things in. But again, that's top timeline. And the reason this is top timeline is because here, S played U in top timeline. This is the first timeline, this is the second. S played U here, so S must be playing U down in this timeline, and likewise R played U down in this timeline, so it must be playing them in this one instead. So I've got either this top timeline where these two played each other first, and then it's kind of reversed in the second timeline. Round 4, T is playing U, so these are the missing teams. And round 5, those are the missing teams. Now let's look at round 4, because P has already played Q, and I also know they played U in the second round. But I also, looking forward, know that they're playing R in the 5th round. So P is not playing R here, and they've also played Q because they played them there. So P must be playing S here, and likewise R must be playing Q. But this is pretty much it, because in this bottom timeline, look, R played Q in this round. So R can't be playing Q here, so the bottom timeline must be broken. It can only be the top that is working here, and we'll just verify that it works. If we look here, S has already played in this top line Q, they've already played P, they've already played U, so they've only got T to play, so that's fine. And then that leaves Q and U who haven't played each other. If you just cross-reference this, that's good. So this is the complete work, so we've got it all correct. Which round will S play against U? Round number 1. One question to go, quite a difficult one. The main key giveaway of this question is these dots, right? These extra dots that aren't doing anything currently, but they've just very suspiciously given you. So we should probably use them. Let's draw some lines. Let's draw some lines to those dots. And more than that, and this is the key insight you need, you also want to draw some lines to the corners. Now the reason I knew to do that was because this dot is not placed randomly. It's placed in such a way such that this distance, and this distance are all the same. And I've done lots of math challenges, so that immediately rang a bell in my head that said, okay, what I should be considering is I should be considering triangles that have the same base. So this triangle has the same base as this triangle. And they also have the same perpendicular height. Because they're going to the same point. So this triangle has the same area as this one. So I'll just call them A. And likewise here, this triangle has the same base as this one because these points are designed in such a way that that's true. And again, the perpendicular height from the base to the point that they are at here is the same. So these triangles also have the same area. And I keep playing that game all the way around. This triangle is also area A because this base is the same as this. Because it said that in the question, and the height is the same as these two, so that's also A. The base is different here, so all of these triangles will be C's with these bases. C, 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 these bases here. And then likewise, this base is slightly different, so all of these will be, I can call D. And then likewise, this one has the same base as these guys, so this one is B. So I've got all our little triangles here. They all have the same areas as their own letters, because the base is the same and the perpendicular heights are all the same. And now I can just write around that A plus B plus B is 10. Just looking at this one here. I can say A plus C is 8. I can say C plus D plus D is 18. And I'm looking for D plus B. Let's make some sense of this. Takes a little bit of trial and error, but I eventually saw that if I add these two things together, I get a nice little symmetrical equation here. So that's just these two added together. And now this is pretty good. I want to remove the A's and C's. So what I'm going to do is I'm going to remove two lots of this equation. So if I double this equation, I get this, and then I can just take these away to cancel all of the A's and all the C's. I'll end up with that. Divide by 2, and I get what I'm looking for of 6. So a dead giveaway there when they gave you those useless points. And then as soon as you thought, okay, I just need loads of triangles. Again, previous math challenges helped me to see that, because I've seen that kind of trick with triangles before. Then it should be okay from there. Somehow just sort out. I mean, it's the last question, so it's supposed to be hard. But yeah, really well done if you stuck through that. And congratulations on preparing yourself well for intermediate math challenges.